guys, I'm Miss Gastler, and we're going to talk about the kinematic equations. And two things: one, I love the kinematic equations and I love deriving them, and two, I have horrible handwriting, and so go find me if you can't read what I write, unless you're not in my class, in which case, sorry. All right, so here's what we're going to do. We're going to start with a couple of definitions. First off, we need the definition of an average, which you probably learned in like middle school. To find the definition of an average, you sum everything up and you divide by the number of things that you summed up, okay? We're going to be using that one today. We also need the definition of average velocity, which is the distance divided by the time, because we're only talking about things that move with a constant acceleration here. The average velocity is what we're going to be looking at, and the definition of average acceleration, which is the change in velocity over the time that it took to change that. And so between those three things, we're going to be able to come up with the kinematic equations. So we're going to kind of write those off to the side somewhere. Actually, I have them written off over there where you can't see them. So if you'll jot those down, we'll be able to use those. Now, some people, for the distance, they use change in x, or they use change in y, or they use d for distance. All of those can be sort of meaning the same thing, and sometimes it might be useful to note that for the triangle, or the change in speed, we might be talking about vf minus vi. Some people write it v minus v naught. There's several different ways that you could note this, and as long as you're consistent in your notation, then that's fine. I tend to use vf minus v naught, which is an interesting combination of those. They all mean the same thing. As long as you have a distinct final and initial speed that you're using, that's going to be just fine, okay? I will be using VF and V naught for my initial and my final speed, okay? So I'm going to move these things out of the way. So to get our first kinematic equation, okay, we're going to take, we'll do the easiest one first, okay? We're going to take the definition of acceleration, that average acceleration, which was the change in velocity over time, and we're just going to kind of expand that out, and we're going to write it in terms of the final velocity, which I suppose if I stand over here, I'll actually be in the picture a little bit more. Here we go. And so that change in velocity, which is Vf minus V naught over the time, okay? And we're going to rewrite this in terms of Vf. So we're just going to use our good old algebra skills to be able to do that. And so when I try to solve for Vf, I'm going to multiply the t across. So I'll have a times t equals Vf minus V naught. If I skip too many steps, stop and go ask me, okay? I'll find someone who knows algebra to help you out through this, okay? And now to get Vf by itself, I got to move the V naught to the other side. So I end up, and I'm going to put Vf on the left, because we usually put that on the left. So Vf equals, and then I have V naught plus AT. So that right there is kinematic equation number one. And I'm going to jot that over here in this corner. So Vf equals V naught plus AT. Okay. That is really useful. There, my head's in front of it. That is really useful for thinking about the final velocity or the velocity at any point in time for an object moving at a constant velocity. Notice that I don't have to know anything about distance. So if I don't know anything about distance or how far it's gone, whether you're using y or x or whatever, this is one-dimensional motion here, so whatever your linear position is, you don't know anything about that for this object, only how far or how fast it's going at 2 points in time, and the acceleration and the time, okay? So that's that first one there. I'm going to move this out of the way. Hopefully you wrote that down. If not, it's a YouTube video. Back it up. Okay. So for my next one, this is the next sort of easy one. I'm going to take and I'm going to combine the definition of the average velocity and the definition of the average velocity. This one's going to be interesting. Okay. So in one sense, the average velocity is the distance you travel divided by the time. And in another sense, the average velocity is the velocity at one point in time plus the velocity at another point in time divided by how many there are. Ha ha ha. I like that one too. It's my favorite, okay? And so now, the way we write this one, for some reason, which I don't really know, we usually solve this one for distance. This one is written in terms of distance, so we're going to solve this one for distance. And then when we write it, for some reason they always write the fraction as a half in front, and so this one becomes distance equals 1/2, and it's a half times all this junk together, so VF plus V naught, and then the time gets multiplied across, so it looks like that. Okay, so that's distance equals 1/2 of VF plus V naught times T. Okay, so that's our second one. Interestingly enough, there's a whole lot of people that don't know that one because it's not very popular of a one to use, but it's one of my favorites. Only because you have to use two different definitions of the average in order to write this one down. So I'm going to write this one over here. 1/2 VF plus V naught times T. That one is a good one for when you do not have acceleration. If you don't know anything about the acceleration, then that is the kinematic equation that you're going to be using. Okay? And that's really the point. All these kinematic equations, you have them because there's something that you don't know. Okay? There's 5 variables: distance, initial speed, final speed, velocity, acceleration, time, and there's one that you're missing, and you know 3 of the others. Okay? And then the fourth that you need. And so which one of these can you use? Okay? So that's what we're doing. So now we have these two, okay? I'm going to mark those off my list over here as the ones that we're trying to get. And now we're trying to get something else. So now really what we need to do is we need to think about what we know and what we don't know so that we can get the next equation. And the next equation that we want to be able to write down is we want to know, well, what if I don't know the final velocity? So I need to take some of these equations and I need to say, I don't know the final velocity. And so what I'm going to do is I'm going to take this first equation and the second equation, and I'm going to stick the first equation into the second equation, because I love algebra. So I'm going to take my D equals 1/2 VF plus V naught times T, and for VF, I'm going to plug in V naught plus AT. Are you ready? Okay. So 1/2 V naught plus AT plus V naught times T. See what I did there? Okay. And so I'm just going to do some distributing, and then we'll do some simplifying. So let's see, I've got to distribute 1/2 times T to everything. So 1/2 T times V naught. Actually, they usually write the V naught T in front. Okay, let's back up. I've got 2 V naughts and T and 1/2. So the 2 is going to cancel out the 1/2. So I'm just going to have V naught times T. Okay, plus 1/2 AT, but I've got an extra T, so that is going to become a squared. Now I can't simplify it anymore, so that's my equation. And so that is what I'm going to write down. And this is what I'm going to use if I don't know anything about the final velocity. So D equals 1/2 AT squared plus V naught T. Now, you see how I switch those around? You don't have to do that. You could leave it as V naught T plus 1/2 AT squared. That's totally okay. In my head, I see the x squared plus x plus blah, blah, blah polynomial format, and I just have to put the T squared first, okay? You don't have to. It's whatever you want to do there. Okay, so there is our third kinematic equation. Okay, and so this one is, oh, I don't have VF. Okay. Now we could also write the one for, oh, I don't have V naught. Looks almost exactly like this, except there's a negative in there because we have to switch the V naught and the VF. And then we put it into the same equation and a negative pops out, but nobody ever uses that one. In fact, it's not even listed on the equation sheet for the AP Physics 1 test. And in all honesty, I've only ever used it like 4 times in the last like 20 years. So if you would like to go through that one and write that one down, you go right ahead. Otherwise, we're going to move on to the last one, which is, what if I don't have time? So now I have to get rid of time, okay? So in order to get rid of time, I'm basically going to do the same thing. And I can use any one of these equations and substitute it into any one of the others. And eventually, I'm going to have to come out with another equation, okay? And so my equation of choice that I'm going to substitute into is going to be number 2 here. D equals 1/2 VF plus V naught times T. And my equation that I plan to substitute into it is this one here, VF equals V naught plus AT, but I need to solve this one for T, okay? So I've got to move this over, VF minus V naught equals AT, and then I got to divide by A. So what I'm going to be plugging in for T is going to be VF minus V naught over A. This isn't looking so pretty, is it? All right, and so, let's see, let's just move that half over here. So I'll have 2D, that way it's out of the way. Thanks, Belle. Okay, and so then we've got VF plus V naught, and then we've got VF minus V naught, and that's all over, now it's all over A, okay? And now you're thinking, man, my math teacher said I would never have to, or I said I would be foiling outside of class, and I didn't believe her, okay? Now, you can go say, thanks, math teacher, for teaching me how to foil, okay? So we'll multiply the A across 2AD, okay? And now I've got VF plus V naught, VF minus V naught. All right, here we go. Oh, this is a difference of things. What do they call it? I don't remember. Okay, so VF times VF is VF squared. Let's see, that's first. Outside is VF times V naught. That's a minus. Inside is VF times V naught, and then the last is minus V naught squared. Ta-da! Okay, this, oh, we're running out of room here. I better, can you even see that? Yeah, you can see that. Okay, these guys cancel out, plus and a minus. And, okay, so I have VF squared minus V naught squared. Now when we write this one, which I'm just gonna write over here, the VF squared ends up in front of the equal sign. And then everything else goes on the other side. So I'm going to add the V naught squared to the 2AD. So it's V naught squared plus 2AD. And there you have it. That's what if I don't know how much time it took. Ta-da! There's your 4th kinematic equation. Okay? That one was by far the most involved. Hopefully your algebra skills are, working out for you today. And that's what it looks like. So before we go, though, we got to talk about, well, what can I do with these kinematic equations other than solve problems, which you can totally do. And there's plenty of problems to solve in the textbook if you want to go through those. It's great fun. I love algebra, and I really love when I have to use like some of the equations together because I only have like some of the information, because they do that to you. What if you only have like 2 pieces of information and you need a third? Oh yeah, it's great fun. Okay. Or you have like they tell you that something is the same, but they don't tell you what it is. Yeah, it's great fun, okay? So they do that to you, but a lot of what they do in the AP Physics test now is they say, well, we don't want you to actually solve for anything. Or maybe they'll ask you to like rearrange an equation. And so you have to do kind of like what we just did to find these equations, but well, now they want you to solve for V naught. So they're gonna give you some letters, okay? Maybe they tell you that the acceleration is Q, and the distance that they traveled was h, and you have to find an expression for the time it takes, and so you've got to solve that thing for time in terms of those other letters. That's something that they like to do. So they have you do algebra without numbers, okay? That's something you're going to have to do on the AP Physics test. One of the other things they have you do is they have you think about how it changes, okay? So if we take an equation like number 3 here, and we write this down, d equals 1/2 AT squared plus V naught T, and the question is, well, let's think about what happens to the amount of time that it takes for something to move a certain distance when it's accelerating, okay? But what if the distance changes, okay? How will the time change? Okay, so when we have to do that, so what if we double the time? What if we double the distance? how does that change the time if everything else is the same? Okay, what happens to the time? And so this is called looking at a change of variables. Okay, what happens to the time? And so a teacher friend of mine who's actually working with me on AP Physics right now, she calls this the rule of ones. And mathematically, that's kind of what we're doing. We're just canceling stuff out. You know how when you divide by the same thing, it turns into a 1? You know, like if I divide all of this by acceleration, well, if I divide acceleration by acceleration, I get 1, because when you have something on the top of a fraction and on the bottom, it turns into a 1. It's all 1, okay? And that's essentially what we're going to do. Everything that stays the same doesn't change, so that's a 1, okay? So what that does is that if the acceleration is constant and the initial velocity is constant, or if it was 0 and it doesn't even matter, that's always great. If it's 0, we can just pretend that doesn't even exist, right? Okay, so if the acceleration is constant and this half, that's definitely a constant, then I can pretend those numbers are 1. And if those numbers are 1, then I don't have to pay any attention to them, because when you multiply by 1, it doesn't change anything. And so what I can do then is I can say, well, distance is proportional to time squared, okay? And if I'm looking at what happens to the time, all I have to do is solve this for time by taking the square root of both sides, okay? So time is proportional to, I'm running out of here, we'll just go like that. Time is proportional to the square root of distance, okay? So if I double the distance in one situation, you can't even see that at all. Let me go over here. The square root of 1 is my first situation. And then if I double the distance, I'll have the square root of 2. Anybody know what the square root of 1 is? Oh, it's 1. Good job, good job. Anybody know what the square root of 2 is? If you said 1.41, I actually think it's 1.44. I totally got that wrong in college. I should look it up, but I don't have a calculator right here, so that's fine. It's either 1.44 or 1.414. I can't remember. It's fine. Either way, is that double? No, it's not double, okay? We did double the distance, but we did not double the time, because it's proportional to time squared, not proportional to time, okay? So they don't change the same, so we have to look at that. But we can look at that by looking at just the variables that are proportional and holding everything else constant and setting it equal to 1, okay? So that's what we can do with those kinematic equations. All right, so this turned into a really long video, but hopefully you got enough out of it about those kinematic equations and how you can use those. If you have any questions, make sure you ask your teacher. Thanks for watching.